Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. So next, let's look at example number 2. Here we have a metal dome. So the metal dome and pipe, which has weight 6 kilonewton. The dome has no bottom, and the value L here is given as equal to 80 centimeter. So we are asked to find the force that must be exerted through the bolt to hold the dome in place. Okay, so now let's consider the forces acting on this dome. So we have water inside this dome. Because of the existence of the water inside the dome, so the water will exert hydrostatic force on the surfaces of the dome, which will consist of the horizontal component as well as the vertical component. So the horizontal component of the force will be acting to the left and to the right directions, and in fact, towards all directions from the center of the dome. But the value will be equal in all directions, so all the forces will just cancel each other. So we don't have to consider the horizontal component of the hydrostatic force. But if you consider the vertical component of the force, so the vertical component of the hydrostatic force will be acting upward, and it will try to push the dome up. Okay, so because of that, you need to apply a force at the bolts here in order to balance this hydrostatic force. So we asked to calculate this force that has to be exerted at the bolts. So let's consider schematic diagram of the dome, right? So consider the forces acting on the dome. So this is the force that we have to apply at the bolt. And of course, the dome will have weight acting downward, right? And then we have the hydrostatic force, which is acting upward in the vertical directions. So if we draw three-dimensional view of this, so basically we have a dome like that. So roughly it looks like that. So the water level is up to here, and then so it's approximately like that. Then you are actually in a boat here in order to make sure that the water will not seep through the bottom part of the dome. So now if you balance the force in the vertical directions, so balancing forces in vertical directions, so we must have F vertical upward hydrostatic force in the vertical directions must be balanced by the force that you need to apply at the bolt plus the weight. So you're asked to calculate this F bolt. So F bolt will be equal to Fv minus the weight. So now let us calculate the vertical component of the hydrostatic force. So Fv is equal to rho T V above. So which volume will be V above? V above will be the imaginary volume above the dome up to the water surface. So that means that if I draw the dome, so this is the dome, kind of like three-dimensional like that. So the water level is up to here. So the volume that we need to consider It's actually this volume here. So if you consider this, the height of this is equal to, since this is 2L and this is 4L, so this height is equal to 6L, and then this radius is equal to 2L. So we can obtain this volume by considering, if we take this cylinder, right? So whereby the height is 6L and the radius is 2L, and then we minus by a hemisphere like that, whereby the radius is 2L, and then we minus again by this small cylinder, whereby the height is equal to 4L and the diameter here is equal to L over 4. So we can calculate V above, which will be equal to this volume here, which will be equal to pi 2L squared multiplied by 6L, because the height is 6L. I minus by the volume of the hemisphere, so 2/3 pi 2L cubed. Then I minus by the volume of the small cylinder, which is pi L over 8 squared multiplied by 4L. And then this is equal to 24 pi L minus 16 pi over 3 L cubed minus pi L cubed over 16, and that gave me 18.6 pi L cubed, which gives me equal to 29.92 meter cube. Okay, so note we substitute L is equal to 0.8 meter, right? So from there we can calculate F vertical. So F vertical is rho T, and V above is 29.92 meter cube. So that gives me 293.6 kilo Newton. Having obtained that, I can now substitute it into this equation in order to get FB. So we get FB equal to FV, which is 293.6 kilonewton minus the weight. So the weight is equal to 6 kilonewton. So that gives me the force that we need to apply at the bolt is equal to 187.6 kilonewton. Okay, so if I summarize again what we did just now, we need to determine the force that we need to apply at the bolt. So if we consider the free body diagram, so the vertical component of the hydrostatic force will try to push it upward, and then we have the weight acting downward and the force that we need to apply at the bolt. So from there, you can balance the force. So F vertical is equal to F bolt plus W, and that gives first expression for F bolt, FB minus W. And the vertical component of the force we can calculate by using the formula rho G V above. So V above is actually the imaginary volume of fluid above the dome. So it's this volume here, which we can obtain by taking the volume of the whole cylinder minus the small hemisphere at the bottom and minus the small cylinder at the top here. That gives us 29.92, and from there we can calculate the vertical component of the hydrostatic force, 293.6. Substitute it back into these equations, and that gives us 5 volts, 287.6 kilonewton.